Hello everyone, welcome again. Now in this video, we will start a new series and it will be a very interesting and important topic series. It's about fracturing design. And in this series, we will use StimPlan, okay, by NSI. It's a very interesting and useful tool for us to do fracturing design. Okay, so let's dig in. We are now inside the StimPlan. It is quite easy, but it's not that easy, by the way. We start with the look of this window. We have data files. We can create new data set here, or if you want to open existing data set, you can use here. We can switch to other files, other StimPlan files. Right now, we are in the recent file. I mean, if you want to open another recent file or other recent files, you can open the drop-down menu here. This is Save button and Save simulation results. And data analysis tool, we have logs. Later, we will use this one. And also pressure rate analysis. And regarding the fracture geometry model, we can do quick simulator. And this is the numerical simulator, more sophisticated, of course. Simulator data, run frac simulator here, the run button. This is to make graphs and report. This is to show the active pump schedule that we will apply in our design. And this is the geological model. And this is the model that we can use, either analysis and design, or 1D fluid flow or two-dimensional fluid flow. If we want to use gridded model, we can select either pseudo 3D or fully 3D. Okay, fully 3D is the most advanced, the most sophisticated, but yeah, it will take longer time to do the simulation. And advanced option, for example, we want to do fracture isodicing, we can use this one. If we want to design fracture that is asymmetric, we can just tick this one, and there will be another computation that will be done by the software. If we have high angle well, or if we want to perform frac pack, we can tick this one. But we will start simple. We will not use advanced option for the time being. And this is for the reservoir model. We can calculate the fault of increase, run analytical reservoir model, analytical optimization, and regarding the numerical reservoir model, we can use this feature. And this is the help button, okay? And this is the quit button. Okay, so that's for the introduction. Now let's go to simulator data. Okay, so there are some data input that we must complete. Okay, we will go through, and right now I have the model that has been populated with data. So I will just voice over. I will just explain it. If you have StimPlan or if you have other software, you can follow my explanation, because there will be no significant difference, I think, between one software with another. Okay, of course, each software has their own advantages, but maybe also limitation. So you can, if you have your StimPlan, you can follow me. But if you have other software, maybe you can get something from here. Okay, so let's start from well data. A well ID is X007. Well type, open the drop-down menu because we want to do hydraulic fracturing. We will inject frac fluid, so type is injection. Treatment, fracturing, acidizing, or frac pack. We start with fracturing, and this is the drill bit, okay, to make the well hole diameter, bore hole diameter 8.5. You can also type in the name engineer, for example, Eng-Man, the company Eng-Man, for example. Treatment through, we will use frac string, and it's actually tubing, okay? Tubing as the fracture string. Okay, so far so good. And then the next section is casing or liner data. We will input ID in inches. String type is casing. Okay, we have casing in our case. The internal diameter is 7 and the length is 3,200 from the wellhead down to the end of the casing, the total depth. And this is the TVD, okay? And it will be calculated using here, using the trajectory that we will provide. Okay, if you want to add, you can click add button, for example, here. But if not, you can click delete. You can also tick this one, automatic pipe friction factor. If not necessary, you can untick. And the next one is completion data for fracturing through tubing or annulus. Here we provide the ID and OD of the fracture string. In this case, we will use tubing, right? And the ID is 2.441 and the OD is 2.875. The length of the frac string or the tubing is 2,800 and the TVD will be computed based on the trajectory. Okay, so far so good. Okay, so this is the graphical input after setting everything up. But yeah, we will arrive to this section later. Okay, so as I said before, I have set up everything. Okay, I have the file in which the everything has been set up. So I will just explain, but we will arrive to this section later. Click OK. All right, and then let's check the perforation.